Alright, so page 149, numbers 10 through 24, says solve the equation and check for extraneous solution. First off, I do want to talk to you about what is an extraneous solution. And an extraneous solution is basically an extra solution. Okay, it does not count as one of your solutions to your equation. Now let me talk to you about why you might have an extraneous solution. Well, when you look at the square root graph, or the radical graph, and you're trying to solve for x, well, just picture a radical that starts above the x-axis and it also goes up. Well, in this case, there would be no solution of x where it would equal 0. So if I had some radical and it equals 0 or something like that, then you would, if you were to solve this, maybe you'd get an extraneous solution. There's also another case where you're solving a square root function, but the algebra actually ends up being a quadratic function. So with the quadratic, you get two solutions, but as you can see with the square root function, you're only going to get one solution. You're not going to get two solutions in a radical equation. So that's sort of a very brief explanation of what extraneous solutions are. And basically, what I'm going to do is just solve these equations, and instead of picking out the situations on where you definitely know there is an extraneous solution, what we typically just say is, you know what, just check all your answers for quadratics, or I'm sorry, for radicals. So the first thing that you want to do is you want to isolate the radical. You want to get all this by itself eventually. Okay, from there you can square, and then we're going to be subtracting 3 and dividing by -2, but we're not there yet. Okay, so what you want to do is subtract 10 from both sides. And when you subtract 10 from both sides, you have 4 times the square root of 3 minus 2x equals 4. Alright, I still have not isolated this square root sign. It's not all by itself yet, so let's get it all by itself. Now, what do you suggest we do? You probably say divide by 4. If I were to divide this left side by 4, that cancels. And if I were to divide the right side by 4, 4 over 4 is 1. Okay, so now we have isolated it just like I asked you to do at the very beginning. Okay, so from here, what we're going to be doing is squaring both sides. If you square a radical, squaring is like the inverse operation of the square root. So if I square this radical, essentially the radical and the square cancel each other out. Okay, and I'm going to also be squaring a 1, which does nothing to the right side, but just square that 1 as well. So here we are, 3 minus 2x equals 1. And now we get to solve this just like it was a linear equation. Up here, subtract 3, so negative 2x equals, if I subtract 3, 1 minus 3, it's negative 2, so negative 2, and then divide by negative 2, and you get x equals positive 1. Now, I'm pretty sure that that's a solution. However, what I want to do is check to make sure that it isn't an extraneous solution. Okay, so I'm going to check x equals 1. And when I check it, all I'm doing is substituting in 1 in for x and making sure that I get 14 on the left side. So 10 plus 4 square root 3 minus 2 times 1. 10 plus 4 square root of 1. 10 plus 4 square root of 1, it does equal 14, so it is a solution. This is a solution. So I'm sorry I was off the screen for part of that, but I think you can follow the work there. I just checked to make sure that the left side was equal to 14, and it is 14. 10 plus 4 equals 14. Alright, so therefore x equals 1 is your solution. Alright, so number 18. As you see here, the square root has already been isolated, so I get to square both sides. Please write parentheses around what you are squaring, because if you just write 3x squared, that's actually incorrect, because this is 9x squared. Okay? Because the 3 is also squared. So here we are, we're going to just say 8 minus 6x equals 9x squared. It looks like this is going to end up being a quadratic. Remember, with quadratics, you want to get everything to one side and set it all equal to 0. So I'm going to be adding 6x and also subtracting 8. 0 equals 9x squared. Add 6x. Subtract 8. Okay, and now there are a number of ways to solve this question. I think most people think to do the Lizzie method. So I'm going to multiply the 8 times 9, and I get 72, and then I ask myself what multiplies into 72 and adds up to 6. I'm sorry, what's the difference of 6 and adds up to 72? So 0 equals x squared plus 6x minus 72. Remember the Lizzie method, you just multiply the 9 times negative 8, get negative 72. So the two numbers multiplying to negative 72 add up to 6, or have a difference of 6 really. So let's just try two numbers that differ by 6. Let's just try 6 and 12. Let's see if that works. Oh, well, that was a good guess. Okay, so I bet one of these has to be positive and one of them has to be negative, since they have to multiply to be negative 72. I think it would be positive 12 and negative 6. X plus 12, x minus 6. And the reason I'm going to say x is positive 12 because positive 12 and then minus 6 adds up to positive 6. Alright, and then remember, as part of the Lizzie method, we have to divide by 9. And it says, when possible, please reduce the fractions and then put the numbers out front if needed. So 0 equals x plus 4/3, x minus 2/3. I'm going to come way up here and finish the problem. 3x plus 4 and 3x minus 2 equals 0. And then we can solve this by setting each one equal to 0. 3x plus 4 equals 0. 3x minus 2 equals 0. And since these are elementary, I'm just going to skip right to the answer. I'm subtracting 4 and dividing by 3. Subtracting 4, dividing by 3. And for this one, I am adding 2 and dividing by 3. Okay, add 2, divide by 3. So now you have quadratic answers. Okay, but remember that you only had a radical. So in other words, what I was trying to explain to you earlier is that you have a radical equation, some kind of radical equation. Maybe it looks like this. Okay. But then you have 3x, which I know more precisely what that looks like. So you can see how the radical is only going to cross that 3x line one time. I guess a line could go through 2 times actually. So as part of my explanation, I'm learning something here. So actually, I guess one of these doesn't have to be extraneous, but in most cases it looked like, yeah, one of them is going to be extraneous. So what you're going to do is plug in -4/3 to the left side and into the right side, and you make sure that you get the same number. So check -4/3. 8 square root of 8 minus 6 -4/3 equals 3 times -4/3. You know what? It's time to use a calculator. Well, let's not. Let's not. Let me take some time here. 8 plus 24/3 is 8. Those will cancel. You get -4. So 8 plus 8 is 16. Square root of 16 is 4. Is 4 equal to -4? No. So this solution right here is extraneous, and you do not include that as your solution. That is an extraneous solution. So how about 2/3? You check 2/3, and maybe you can do it in your head. I'm not sure. No, I doubt we can do this one in our heads. I know I have 2 over here, but 8 minus 6 times 2/3. And basically 8 minus 6 times 2/3. So under the square root sign, and then equals 3 times 2/3. So that is 8 minus, those cancel and you get 2. So 2 times 2 is 4. So 8 minus 4 in the square root sign. 3's cancel, you get 2. Square root of 4 equals 2, and we know that that's true. So square root of 4 equals 2, and that's true, so this is a solution. Alright, x equals 2/3 is the correct solution. And lastly, number 21. We are going to first off notice that the square root's already isolated. So we're going to square both sides. And this is very important here, that it is very tempting to say x squared plus 9. It is not x squared plus 9. It is x plus 3 times x plus 3 equals 2x plus 21. X plus 3 times x plus 3 gives you x squared plus 3x plus 3x plus 9. That's 2x plus 21. And then your question is, why can't you just square it and say x squared plus 9? It's not. It's not x squared plus 9. It's x squared plus 6x plus 9. Okay? So you're forgetting about the middle term if you just square it like people so often do. Okay? So we're going to take this and just solve it. It is a quadratic, remember, because it has a squared sign, so get everything to one side. So in other words, subtract 2x, subtract 21. 9 minus 21 is -12, and it equals 0. And we're going to solve this by factoring and then using the zero product property, just as we did the last question. So what multiplies into 12 adds up 4. I'm thinking 6 and 2 somehow. Positive 6, negative 2. So x equals -6, x equals 2. And then you're going to check both of your answers. Check -6. And you go back to the original equation and plug it in for x. -6 plus 3 does that equal 2 times negative 6 plus 21? Negative 6 plus 3 is a negative number. A negative number is probably not going to equal the square root of some number. So I'm guessing that this one's going to be extraneous. 21 minus 12 is 9, square root of 9. And negative 3 does not equal 3, so therefore negative 6 is extraneous. So do not include that one as your answer. Now take 2 and check it. Check 2. And 2 plus 3 equals square root of 2 times 2 plus 21. 5 equals 4 plus 21, 25. So 5 equals 5. So x equals 2 is your answer. And we've checked it and made sure that it works. Okay, so God bless. Hope that helps.